Hi everyone, I am Bindeswar from PostNetwork Academy, and in this video you will understand Poisson distribution. So let's get started. A random variable x is said to follow Poisson distribution if its probability mass function is e raised minus lambda raised x upon factorial x, where lambda is a parameter and x takes values 0, 1, 2, 3 and so on. So x takes values 0, 1, 2 which are discrete. So Poisson distribution is a discrete distribution. Now if you plot graph of mass function, so you can observe that when the value of lambda is small, it has high peak. When the value of lambda is increasing, so it is becoming symmetrical. So when lambda increases symmetry, it becomes symmetric. We will discuss also this property in skewness. Now let us find moment generating function of x. That will help to find expectation and variance. So moment generating function of x is empty summation over x is equal to 0 to infinity etx fx. So if you see the moment generating function of random variable x, that is empty is equal to e to the power lambda et minus 1. So using this moment generating function, we can obtain expectation and variance. Basically, expectation is the first moment. So how will you get first moment? So you will differentiate moment generating function and put 0. So you can get first moment, and first moment is expectation. That means Ex. That is the first moment. Ex square second moment. Ex cube third moment. Ex4 fourth moment. Now if you want to find second moment, so differentiate it with 2 times and put the value of t as 0. So it would be equal to lambda plus lambda square. Now variance, you can see that is defined at e second moment e x square minus x square of expected value, that is again lambda plus lambda square minus lambda square is equal to lambda. So in Poisson distribution, expectation and variance are equal, which is equal to lambda. Now let us discuss the skewness of Poisson distribution. So skewness is associated with third moment. Other terms will require, but basically it is associated with third moment, and it is equal to 1 upon under root lambda. So Poisson distribution is always skewed distribution. In limiting case, if lambda tends to 0, so there would be 0 skewness. That means there would be not lack of symmetry. That means it will be completely symmetric. And if you talk about kurtosis, so kurtosis measures flatness and thickness, which also depends on lambda. So if lambda tends to infinity, so kurtosis would be 0 and it would be like normal distribution.